Hey there, you're with Mr. Laurie, and this is Linear and Nonlinear Relationships Part 3. So far we've looked at straight lines, and in this lesson we'll be finishing off our straight lines section. Today we're going to be looking at using coordinate geometry. So there's no notes as such. We've got the skills from our review and our work on parallel and perpendicular lines. Today we're just going to be doing two examples. So let's get started. Here is our first example. In the diagram you can see that we have a triangle formed by the points O, that's the origin, 0, 0, A, the point 2, 3, and B, the point 4, 0. Now E and F, they're the midpoints of OA and AB. Our first job is to show that triangle OAB is isosceles. What do we know about isosceles triangles? Yeah, that's right. We know that they have two side lengths that are the same. So if we can show that distance OA is equal to distance AB, then we'll have proven that it's an isosceles triangle. So it might help to recall the distance formula. x2 minus x1 squared plus y2 minus y1 squared, and we take the square root of all that. So looking at points O, which is 0, 0, let's call that our first point, x1, y1, and A, that can be our second point, x2, y2. Now x2 take away x1, that's just 2 take away 0. So that's 2. And y2 take away y1, that's 3 take away 0. So that's just 3. 2 squared is 4, and 3 squared is 9. When we add those together, we get 13. So our distance OA is the square root of 13. So that was for distance OA. Let's now compare to distance AB. For AB, we're using two different points. We have x2, y2 already labelled for point A, so let's just keep that as x2, y2, and point B will now make our x1, y1. Okay, so x2 minus x1, that's 2 take away 4. 2 minus 4. And y2 minus y1, that's 3 minus 0. Alright, now 2 take away 4, that gives us negative 2. And 3 take away 0 gives us 3. Now even though we got a negative number, we're squaring it. So the result is positive. Positive 4 in fact. 3 squared is 9. So once again we've got 4 plus 9 is 13. So distance AB is also equal to the square root of 13. That's exactly the same as OA. So therefore, triangle OAB is isosceles. Okay, the reason being two equal sides. Okay, remember it's always good to put in our reasoning. Alright, second part to this example. We need to show that EF is parallel to OB. So this line here, EF, can we show that that is parallel to OB? Remember from last lesson that to show two lines are parallel, we need to look at their gradients. E and F are the midpoints, so it would be good to know what are the coordinates of these points. So let's look at our diagram. If E is the midpoint of OA, and O goes from 0 to 2 along the x-axis, the x-coordinate of E must be 1. Vertically, we go from 0 to 3. So E must be 1.5 on the y-axis. So that is the coordinate of E. Similarly, we can look at F and see that it has an x-coordinate of 3 and a y-coordinate of 1.5 as well, because we're going halfway between 0 and 3. Since E and F have the same y-coordinate, of 1.5, we can see that EF is horizontal. Now OB is obviously horizontal, right? Because both those points lie along the x-axis. If both lines are horizontal, EF must be parallel to OB. Alright, that's our first example. Let's have a look at a second example now. What we have here are 4 points, W, X, Y, and Z, and these are the vertices of a quadrilateral. W is -3, 0, X is 2, 2, Y is the point 4, 0, and Z is the point -1, -2. The first thing we need to do is show that WXYZ is a parallelogram. So how are we going to do that? Well, what do we know about parallelograms? We know that the opposite sides are parallel, and we know how to show that two lines are parallel. All we have to do is show that they have the same gradient. So let's start off by working out the gradient of WX. W can be our first point, x1, y1, and x can be x2, y2. Gradient is y2 minus y1, so that's 2 minus 0, over x2 minus x1, so that's 2 take away -3, so that becomes a plus, and we get 2/5. Let's compare that now to ZY. What is the gradient of ZY? Y can be our first point, x1, y1, and Z can be x2, y2. Y2 minus y1 is -2 take away 0, over x2 minus x1, which is -1 minus 4. Simplifying, we get -2 over -5, and the negatives cancel, so we get 2 over 5. So that's looking good. WX and ZY have the exact same gradient, so they're parallel. Let's have a look now at the smaller sides, or the shorter sides I should say, of the quadrilateral. Let's start with the gradient of WZ. Y2 minus Y1 gives us -2 minus 0. And on the bottom, we have x2 minus x1. That's negative 1 minus negative 3. So that becomes a plus. Simplifying, we get negative 2 over 2. So that is a gradient of negative 1. Finally, let's look at the gradient of xy. y2 minus y1 gives us 2 minus 0. And x2 minus x1 gives us 2 minus 4. Once again, when we simplify, we get a gradient of negative 1. So we can summarize as follows. Wx is parallel to zy because of equal gradients. And Wz is parallel to xy because of equal gradients. So, because opposite sides are parallel, Wxyz is a parallelogram. A short way to write that is parallelogram. Opposite sides parallel. That's our reason. Alright, what about part B? Part B was to show that the diagonals bisect each other. Now, they must meet each other at their midpoints. So if we can work out the midpoint of wy and xz and show that it's the same point, then we'll show that the diagonals bisect each other. Now, because w and y both lie on the x-axis, it's quite easy for us to see that from negative 3 to plus 4, the middle of that is 1/2. So the midpoint of wy is 1/2, 0. But we also need to show that that's the same midpoint for zx. So, using our midpoint formula, where we add the x-coordinates together and divide by 2, we get 2 plus negative 1 over 2. And we add the y-coordinates together and divide by 2, we get 2 plus negative 2 over 2. And when we simplify this, we will have the midpoint of zx. 2 plus negative 1 is just 1, so 1 over 2 is half, and 2 plus negative 2, well, that's 0, so we get 1/2, 0. Since this is the midpoint of both diagonals, the diagonals must bisect each other. And that is the end of our second example. So we looked at two examples where we used various skills, distance, gradient, midpoint, to prove properties of triangles, quadrilaterals. We used our coordinate geometry to study some more regular geometric problems. Thanks for watching.